Okay, so Shubham Tripathi here.
Yes, sir.
Okay, fine. So Shubham, you have applied for the data scientist role in our company, right?
Exactly, sir. Yes, sir.
Okay, so Shubham, tell me about yourself.
Sir, my name is Shubham Tripathi, and I have graduated in civil engineering from Guru Gobind Singh Indraprasth University. And after my engineering, I did a few internships in civil engineering. But later on, I came across my friends who talked me into data science, and then I uh, did deep machine learning and deep learning algorithms. I studied them, I practiced them, and that is why I have very much influence in it. And I have a bit of knowledge about web development and data structures. And I think that would be it about me.
Okay, so you are saying you are from civil background and you got what is the type of interest you have got in the data science? Means I can say what are the things or what are the things that you have seen in data science which you are lacking in civil engineering?
I personally feel like, first of all, EDA, like exploratory data analysis and all, you get a lot of scope and you can do a lot of things over there. And I think in this field, there is so much amount of scope that you do EDA. And like if I talk about algorithms, different algorithms like K-means and SVM and all. So these all, they give me the opportunity to get out of my comfort zone and actually learn something new and apply it into day-to-day lives. And as we know, I personally feel that data science is the future in tech. So I think that's one of the few things.
Okay, fine. So you have learned about machine learning, deep learning, NLP, and RL, right?
Yes.
Okay, fine. So I'm giving you a chance. You have to choose one topic, okay? And I'll ask you questions on that basis. Okay, you have
uh,
to choose one topic.
I would say KNN, K nearest neighbors. I think that is one thing which I really like. So
Okay, okay. Then explain KNN.
what happens
Explain.
here is, like for example, I have a few data points, and let's say I have this type of data, and let me just change the color. And like say for example, there is another data point, and I want this, like I want to cluster it, or I want to see that which category it belongs. Or let's say if I say that these are my let's say apples, right? And I have another one. If I put it by dots, I have mangoes, and I bring something and I want that which category does it belong. So what I would do is, generally, I mean, this is a pretty weird example, but like we calculate distances. Okay, so we calculate the let's say if I have k is 3, so I will calculate the 3 nearest neighbors, as the name suggests, or the minimum distance between 3 closest data points. Or you can say, like I said, if a practical example like vegetable or something, like, I mean, vegetable I don't think is the correct example, but let's say distances, like if I have data points, and then let's say these are the data points which are closest, and I will form a circle. But what happens here is, like I get another data point which is not of the same category, but like this became 4, but let's say this is the closest one. I personally feel this will be the cluster. So I have maximum of 2, so I will categorize that this data point belongs to this category, because the majority of them are there are 3 nearest neighbors and 2 belong to the same category, so it will take the majority. And this is how KNN works. And like here you can categorize in this particular manner.
Okay, fine. Uh, okay, fine. That would be good enough. Let's just clear it and see. There is something known as scaling. Okay. So I'm just asking, why do if we need to scale our data for the KNN algorithm?
Actually, what happens is, like see, if I have a lot of like I have a lot of features, right? So there is a possibility, like let's say if I have distance between 2 houses, so that would be in meters, right? But if I have another data point which is like between different states, if I say cities, so that would be in kilometers. So like if we are when range, not kilometers, let's say, like there are very some data points would have values in like 1, 2, 3, 4. Let me just remove this example and take a very generic example. Like I have 1, 2, 3, 4, and there is another feature which has values in 1000, 1000, and let's say 300 and something like this. And when I apply my calculations in these two, these are very different values. So the calculation and the output, the answer which I will get will not be of the same order, right? So what I have to do is I need to scale it down in a manner that both of these are on the same particular platform. Otherwise, what will happen is like my answer would be very absurd, right? Because if I, let's say we calculate Euclidean and Manhattan distances. So if I my Euclidean distance is x2 minus x1 whole square plus y2 minus y1 whole square. So like if I do the distance difference between these two, that will be 999 the whole square, and similarly something here. So that would be a very absurd value which might not be true in most cases. So that's why I have to bring it to the same scale, so that whatever calculations or manipulations I do, they are when both of them are at the same level. So this is the purpose of scaling in KNN.
Okay. Okay, done. Let's just see something more exciting. Euclidean distance and Manhattan distance. I just want to know the formula of both.
Okay. So Euclidean distances formula is x2 minus x1 whole square plus y2 minus y1 whole square. This is the general distance formula which we all learn in younger classes. And Manhattan is slightly different. It's y2 minus y1 modulus plus x2 minus x1 modulus. So this would be the formula for both of them.
Okay, and then what is the difference between Euclidean distance and Manhattan distance?
Actually, what happens is there are certain cases, like if I have to travel in an airplane from Delhi to Agra, so my shortest distance will be this, right? So I have to calculate the shortest distance in a straight line. So in that case, Euclidean is the best. Like this is like in Cartesian system, right? So your shortest distance would be the different coordinates and whole square. So here it's okay. But what happens when I have to travel it in city? So now I have one house over here, one house over here, and there are some houses or some obstruction here. So I can't travel in this manner. So Euclidean is not effective here. So how will I travel is, first I will travel in this way, and then I will have to travel in this way. So this is the map how Manhattan cities, roads are designed. So that is how the name came up. So here I travel. So what happens is this is y2 and this is y1. So this becomes y2 minus y1. So this is something which I traveled, and then I traveled here from x2 minus x1. So and that is why that we just calculate the difference between these two and add them up. So this is the basic difference between the two distances.
Good, good. That is clearly understood here. Now I want to ask that why we would not use KNN on larger data set. Did you know that we cannot use KNN on larger data set?
Yeah, I had a rough idea.
What is the reason?
Actually, I am not very clear about it, but I have a rough idea. Actually, see, what we did earlier on was I have some data set and I have to calculate it, the nearest neighbors. When I have K3 or K5, that's okay. But when I have a very large data set, then I have to take a higher value of K, obviously, because see, what will happen then is we might get overfitting, because if we take a smaller value of K and I have some values here and it's a very huge data set, then here there might be completely different values compared to here. So that is why when we have to take a larger value of K so that we also engross this parameter. But then again, there are so many different values, and then it becomes like, see, if I take a very large value of K, let's say I take K as 100 and I have 51 values of a parameter and 49. So by the basic principle, we have to take the unknown point as the one in which point the cluster is 51. But 49 is also a very significant number in that cluster, and in that case, KNN is like, it won't give accurate results, and that this is actually a very brief idea about why we don't use KNN in larger data sets.
Okay, fine. So do you know something about SVM?
Yes, I have a brief idea about it. Yes, a little bit.
What is the full form of it?
This is special vector machine. Support vector machine, sorry, support vector machine, sorry.
Oh yes, support vector machine, not special vector machine.
Yeah.
No problem. Can you just explain me in a brief way? In a brief way, you have to explain SVM,
Right.
and you can start.
Yeah, right. Let's say I have this axis and I have a few data points here, 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 and here. And let me just change my color. I have a certain data points here. And generally what we, one second. No problem. I just give you 1 second. Right. So I have certain data points over here and I have certain data points over here. Now, if I have to classify them, I can create a certain boundary, right? So there would be data points here and there would be data points here. This is known as hard margin classification because this is the line. If I have something here, it will be very difficult for it to classify. So what we do is, because it's not, see, if I have some data which is not in a particular category, so I have, see, if I have something like this, so it is very difficult. It's coming very close to the boundary. So for this, I can create a buffer zone, right? So if I create a buffer zone here and I create a buffer zone over here. So what happens here, I give this, see, this is known as hyperplane as per technical, it's a technical name is hyperplane. So what happens here, it gives a certain buffer in this zone and in this zone. So if I have some value here or some value over here, so it will be categorized accordingly. So this is the basic purpose of SVM, so that we give a certain buffer to our categories and don't do any type of hard classification, like hard, as in, it should not be like if I have certain value, like let's say we say 18 years is an adult age, right? So it's a very hard classification. As soon as you turn 18, you are adult, but you are 17 years and something, you are not an adult. So this is something as hard classification. But when we are going into like when we started our BTech, first year is mostly like related to 12th. So that's a certain type of buffer. So this is what we try to create in our data set, so that we don't, we don't get a very hard classification, that certain data lying very close to the boundary is not like our model is not able to classify it. So we try to create that buffer. So that's the basic principle of SVM.
Okay, fine. So you know about wait a second. You know about this loss. It is very popular in SVM, that is the hinge loss. Do you know about it?
I know, like it's more about your a hinge loss is like see, what happens is when our data is very close to the boundary, we give some penalties to it, right? So the penalty, how, see, our data is more like in the format of y and w transpose x plus b. So this is our bias. So if it is greater than or equal to 1, so it's the hinge loss is 0. So this is something we give so that the buffer that we were trying to create, we can create it easily. And if it is this value, if this value is less than 1, so what will happen is our losses, the hinge loss is going to be increased significantly. So this loss actually represents that how much close our data is to the buffer, and like it's more about how precise it's going to be, because see, if some data is here or some data is here, it's not difficult to classify it. But if some data is in our buffer zone, that is very difficult to classify, and that is why we define hinge loss. So this is a parameter which it has to follow, so that we don't get a significant amount of loss, and our model is good enough for classification in SVM.
Good. So let's say you know about kernels.
Yes.
In SVM.
Yep.
Okay, there is one kernel known as polynomial.
Yeah, right.
So can you explain it in a short way?
In a short way, right? So what happens is, firstly, in kernels, what we understand is, if I have certain data like this, and there is another kind of data which it's encircling it, right? So what will happen is, I am not able to classify it correctly, right? So what I can do is, I can create a like kernel. So it will be I have to create this 2D figure into a 3D format. So that is where kernels are used. But what will happen if like I have to create a certain circular region in this boundary, right? So that is where polynomial kernel comes into play. Like if I have a polynomial type of expression, let's say y square x plus y. So something like this, if this is my data, that is when my I have to classify this, right? So here what will happen is there will be certain type of like it's very difficult to create a 3D model, but it will be something like this. So this will be like this is on top and this is following a type of hill structure. So this is where kernel comes into play. But even in this hilly structure, I have to create a polynomial. Like here, if for this type of data, I have to create a circle, and that is where kernel comes into play. That we use if data is embedded in our the larger set of data, and then I have to create. I can't classify this by a straight line. So that is where I have to use a polynomial kernel, which will be a circle, or in this case, it will be a circle, but in another type of case, it could be a different figure.
Okay. So I think that would be end to this interview. Okay. And we are pleased to have you on this interview. So do you have any questions for me?
Sir, I feel if you could just guide me a little bit, like I am coming from a different field. So how was the interview, and a little bit like how I can improve?
Okay. See, your interview, I can say it was good. Okay, it was not bad. It was just good. Not better one. Yeah, I think it is in the middle way. Okay, not a best one or not a bad one. Okay, it is good. And for switching your field, you need to work on the different projects. Okay, well, because project-based learning is much more scheduled than book-based learning. Okay, it is very important to use some project because you will get on some hands-on programming facilities. Okay, so then you will be when you will be going to a company, they will also give you one real-time problem and you have to solve it by using the skills of machine learning, deep learning, or anything. Okay, so project is more important. And second interview was good. Okay, but just focus on your projects. And then when the topic came, okay, when the topic comes, like for example you are doing project in SVM, okay, then study this topic. Okay, first of all make a project, and you need to know that where is a kernel, whether it is a RBF kernel, okay, whether it is a poly kernel, what are these kernel doing, okay, and what will be the best one for your project.
Yes, sir.
So this type of learning is specific. Okay.
Okay, sir.
Anything else?
No, sir. Thank you.
Okay, thank you. We will be contacting you soon if you are getting selected. And thank you so much. You can leave up.
Yes, thank you, sir.